Hello, and welcome to week 2 or lecture 2 of reproducible research in R. This is a course being taught by me, Tad Dallas, at Louisiana State University in biological sciences. It's aimed at upper level undergraduates or beginning graduate students and is aimed at teaching tools for reproducible research. So the first lecture went over just a general background of what reproducibility means, why it's important, and then a little bit on Markdown, which is a markup language used across many different interfaces, like in GitHub, the issues and other things, as well as in Slack, which many of you may use, and things like that. And so today we're going to get into a couple more tools that we can use, as well as why we would use them. The why we would use them is more reserved for a discussion that will happen in conjunction with recorded lectures here at LSU. But I'll touch on some points that I think are pertinent or relevant. And so what we'll be going over today is the Unix Shell, and then there's a separate sort of recorded lecture, which I may just attach to this one that I gave previously as a workshop on how to use Git and GitHub while I was a postdoc at University of Helsinki. And much of the content is still there. It seems like it covers all the important bits, and so I think I'll just reuse that. But go into more detail if students still have questions in the other lecture that's not publicly available on YouTube. And so this lecture will just focus mainly on the Unix shell. And the Unix shell is basically the way you interact with your computer on a base level. And so the most direct level you can. So instead of clicking on your file manager, whatever that may be. So it's My Documents or something like that in Windows, or whatever file manager you're using. And so I think Ubuntu base uses something called Nautilus as the file manager. And that's just a graphical way to display your files. But instead of doing that, we can actually access it just simply through the command line itself. Why this is important is because a lot of the tools that we'll be using sort of require the use of the command line. And the command line itself is really, really useful in terms for speed. So changing between directories, opening files, making files much faster to go through the Unix command line, at least once you're used to it. As well as just transparency. And so it's actually a quite powerful tool once you get to use it. So, and then some things just don't work outside of command line. And so things like Pandoc, which is a document conversion platform software, I guess, only works through the Unix command line. As far as I know, there might be some graphical user interface out there. And so I'll close that. I'll be teaching Unix command line through RStudio. And many of you may scoff at that. I think it is great for beginners, especially people who are already using RStudio to develop their R code. So RStudio is an integrated development environment, or IDE, for keeping all your R code and running it sort of in the same GUI. This will be a little bit of a challenge since I'm not used to RStudio, but that is good because it places me on the same level or below the level of many of you out there, I'm sure. It's also sort of good to know that I'll sort of incorrectly use words like shell and bash and other things interchangeably. Bash is simply one flavor of the shell environment as far as I understand, and that stands for born again shell. So there's many other different terminal emulators out there. The one that ships with Ubuntu is just the GNOME terminal. Okay, so I'm going to go ahead and share my screen, and it'll be an RStudio console, and we can get this going. But okay, I'm going to share the entire desktop actually. So I'm running two different screens, and now you should see the one screen. Okay, and so you see an RStudio space. And what you see is just the RStudio console itself, or sorry, the R console itself embedded in the RStudio graphical user interface. And so this is the same exact thing that we'd get if instead of using that, we were to use the shell. So on the left, I have the Unix shell, and how it's structured is username at what the computer name is. And you enter in commands directly into here. And so let's say we want to start R from the shell environment. We can do that just by typing R, capital R, enter. And it should say the exact same thing as the RStudio. Okay, that may seem sort of natural, but I just want to sort of draw that comparison. Is like basically most things that work from GUIs, that's not true. A lot of things that work in GUIs also work from command line, but sometimes it just pulls up the GUI. So we'll quit that and exit that Unix instance, and we'll use RStudio instead. So RStudio gives you the R console, but it also gives you the ability to open up and access the terminal. This assumes that you have an operating system which allows you access to something like a bash terminal. So Windows users, a lot of times they've had to use something like PowerShell or things that are supposed to sort of roughly emulate the Unix subsystem. As of Windows 10, I believe you should have access to the bash shell. I provide a link in the lecture notes, which are available on the GitHub website, about how to actually get that access. So hopefully we'll have no trouble getting you the access that you need to the actual shell, to the software that we're using. So hopefully by now you've installed R, you've installed RStudio, and you have access to the Linux shell, or the Unix shell. For people in the course, I'd like to reiterate that I do have persistent Ubuntu flash drives that you can use. And so that basically just sets up the entire operating system for you. It'll come, if I'm not lazy, it'll come pre-installed with the most up-to-date version of R. It'll have RStudio on it. It'll have Git. It'll have make. It'll have all the things that you need that we'll go over in this course. Okay, so share screen, we're good. And what we're going to do is access the actual terminal. So to do that, you'll go into Tools, and you'll go to the terminal command, and you can either do move folks to terminal or new terminal. And what that does is it creates the same thing that we saw when we opened the other terminal emulator. So this is just a way to get into the terminal. Okay, so now that we're here, we went over the structure. And so I am Tad, that's my username. I'm on a computer at home because of the pandemic called Serenity. And I am in the downloads folder. And so this is the path in the Unix, in the Ubuntu subsystem. Away from home, I'm in downloads. And if I didn't know where I was, and so I could easily get information on where I was by using the pwd command, which means print working directory. And so in the Unix subsystem, this says that I am in my home folder, and within my home folder, there's a folder tad, and within tad, that's my user, and within tad, there's a folder called downloads. And so we can also move around to different directories. And so let's say we want to not be in downloads. We would like to be at a higher level. We just want to be in a home directory of tad, the user, me. We can use change directory, and we can either specify that we want to be in home or tad, like that. And I'm going to change back into the downloads. Actually, first I will print the working directory, and it says I'm home in tad, home/tad. Or we can do using sort of relative paths. And so this is a really useful little bit where if right now, okay, I'm going to change back into downloads. So now we're in downloads. let's say I want to move up a level, but I don't want to type out that entire path. Like, why would I need to type out /home/tab when I just want to go one level up? Because how the subfolders work is they're all nested, right? So we have home up top, and then beneath that, nested within that folder, we have tab, and then nested within tab, we have downloads and other folders. So to change into just one level up, I would just use this dot. And so when I say change directories dot, and I do print working directory, it just moves me one level up. You can chain those together and actually link. And so you can chain it like this, which would move 2 levels up, etc. And this is useful not only to the Unix command line, but also in a lot of R code. And so I consistently see people's code where they set the working directory to be some folder on their computer that's like C://project1, and it's just this huge nested path. But if you want to share that, like, I don't have that folder. That's not the way my stuff is set up. And so using relative paths is really important. And knowing where the path is. And so typically what you want to do is, instead of providing that set working directory command, is you want to just provide a relative path, assuming that the user is already within the folder containing your analysis. We'll cover that later in terms of like tips and tricks and when we go over, but it's just a little bit of good practice sort of now. So we've gone over print working directory, fantastic command, as well as change directory, CD. And this is good for navigating around in different subsystems. However, sometimes you just want to know sort of what's in a given or like folder or anywhere in sort of file system. And to do that, and I think this is maybe one of my most used commands, is just ls. And so that lists everything that is in your given folder. And so you'll see a lot of random stuff. Yeah, none of which is incriminating or anything. I have a random file called notes to self. That's probably bad practice. As well as just information on other side projects or other things going on. So I recently completed campus advisor training for GitHub, and this was the repo that I developed in. Not as organized as it should be, but say la vie. And so this gives us information not only on files, but also on what folders are. So folders are in blue, files are just in black. But let's say we want to know more information, right? And so all of these things are functions, right? So print working directory is a function that acts on the existing file directory and produces something. So for every function or command line operator, there should be, hopefully, a help file that corresponds to it. And we can access that by using 2 dashes and help. And so when we go into this, we actually see that ls, despite it being a simple command, actually has a quite extensive help section. So these are all the different arguments that you can give to help. And the typical usage that you want to look for is ls, and then it has option, which are these flags. Options are different flags that say like that you want certain information, or that you want to filter information, or you want to provide more information. And the most useful one that I've used sort of consistently is this -l, which is to use long listing format. And so basically this allows you to see things like file size. It allows you to see when it was modified last. It allows you to see all this information. And so we'll just do that. Where we say, yeah, so the owner of it, it gives you information on permissions. And so do I have permission to write to this directory? Do I have permission to read it? And then we have information on overall size, when it was modified, and then the file name. As well as the number of files, I guess, within that. Is that number? I'm not sure about that. Yeah, and so help is a really useful thing. In addition to help, there's the command man. So that stands for manual. So if we wanted to see the manual of ls, or maybe print working directory has one, it does. Of course it does. Then we can type in man pwd, and it comes up and it provides the name, it provides all the options. There's very few options for this. So that's incredibly useful. What I did there was just the clear command. So whenever things start to get long and you're like, this is too much information, you can just type in the clear and it clears out all the garbage, all the previous commands, and just gives you the blank terminal. So we've gone over change directory, print working directory, ls, and then how to get help, which is incredibly useful. So let's go, where am I at now? So I'm still in my home folder. I can see that by using print working directory. And now let's say that I want to list I only want to list files that are spreadsheets that end in CSV or that end in a certain, let's say MD. So we just learned Markdown. We know that they end in .md. And so how we can do this is using wildcards, which is a really useful thing. And we'll go over it a little bit more probably later. Like, this is not the only time we'll encounter wildcards. And basically, so we have our ls command, but I don't want to print everything. I only want to print a subset. I only want to print things to the screen that have .md at the end. And how we can do that is by using the star symbol, or yeah, I guess you call it that asterisk. I'm gonna say star symbol, .md. And so that means that this can be anything as long as it ends in .md. And when we hit enter, we see that there's 4 files that correspond to this, that are markdown files. All right, then we'll clear that. There's some other things that I'll go over. In the lecture notes, I just sort of say, oh, there's a few other important things, because I wasn't sure how long I would go on about Git and GitHub. But I will use that previously recorded demonstration, which is about half an hour long. And so this one, I'll try to keep around half an hour or less, just so people don't get, and students don't get too overwhelmed. However, I do think these tools are incredibly useful. And so let's say I want to just make a project. I have some data coming in and I'm like, I'm ready, let's do this. And I don't have an existing template. And so we'll go over sort of analytical workflows and templates, I think, next lecture. But in this one, let's just assume that we don't have any previous sort of design template. So we want to make a new folder that's going to contain different files with our data and with the analyses and the manuscript. And how we can do that is using the mkdir command. So this is make directory. And we have to name our directory something. And so for the sake of this, we'll name it test, but that already exists, because this is actually the second time I've tried to record this, because the first time Zoom just crapped out. So hopefully that doesn't happen again. So let's name it something else. You know what? No, let's get rid of test. Right? So instead of just going to your file manager and right-clicking and saying delete, or like dragging it over to a little trash can, what we can do instead is just use the rm command, and we can remove test. But I'll tell you already, this isn't going to work. And so we can hit enter and it says cannot remove test, because test is a directory, right? Which means trying to delete a directory means deleting all of the files within it. And it just won't do that, which is good, because maybe you don't want to delete all the files within test, but if you do, there's a flag for that. And that's -r, which means recursive deletion. So it's not only going to delete the folder, it's going to delete everything within that folder. And there we go. And so now we can use ls, and we'll say ls test. There's no such file or directory. Doesn't exist. I deleted it. Okay, so now we can make directory, oops, missing operand. See, it has very informative error messages, which means I didn't name the folder that I wanted it to make, or the directory that I wanted it to make. So let's make a directory called test. Now when we say ls test, it returns nothing, but it's there. It at least doesn't error out. And let's change directory and go into this test directory. So now we're in our test directory. It contains nothing, but we've made it. Cool. Took us very little effort. More effort than it should have. That's because it already existed. And let's say we want to create a file now. And so we can use the touch command to just create a base empty file with some formatting or ending. And so if we want to make a markdown document, for instance, we'll call it, let's just call it Readme. So it's always good to have a Readme file in the top level of a project directory, which just gives information on what the project's about, what the files do, what they mean, who contributed to it. The Readme is incredibly useful. It's basically like your project's metadata in a sense. And so that also returns nothing, but now we can use ls and see we have made a file called Readme. And so let's say we want to add text to this file. What we can do is we can call a text editor from the command line. There are several text editors that sort of live within the terminal, if that makes sense. So things like Vim or Nano, they live within. So you call the program Nano to run this file, Readme. And what it does is it doesn't open up a new thing. It just gives you access to it, the file from within the terminal. This is not like ideal for many users. This won't work if you don't have like Nano installed, which I don't even know if it's available for Windows or Mac. It hopefully is, but I don't know. Yeah, let's just exit out and show you another way. And so you can edit and anything, but basically any of your text editors will be available from command line, right? And so the default that ships with Ubuntu is gedit. And so we can say gedit readme, and then we're going to end it in an ampersand. An ampersand orphans the process. So it opens it up, but what if I were to like close down the terminal? If I didn't orphan the process, it would close not only the terminal, but also whatever I was working on. And man, I've been burned by that one before. When I was first learning. So that's good. It's always good to orphan the process. And so that opens up a readme .markdown that's in the test folder in this separate text editor. And so we can add just random text. And so we'll go down about 30 lines just for fun. And so now we have a 30-line document. We save it, and it's just a bunch of random things that say test, and then we can close it. Okay, so now we have this README. It contains something. Let's say we want to know what it contains. We can use things like word count or WC. And so we do word count README. And that provides information on the number of lines, the number of characters, and the number of total words. Yes, so that's characters, 30 lines, 11 words, all of which are the same word. Also, you can, so if you have really large files where maybe you only want a bit of it, you can use things like head and tail. And so if we see head of README, it's only going to print the first 10 lines to the console. So those are the first 10 lines. If we use tail README, we'll see the last 10 lines. And we'll use clear to clear out all the junk. Doesn't really clear out the junk, just gives us a fresh terminal. Okay. So let's say that we have data that's not in this folder, but we want to move it over. And we don't want to just hit like Control-C on like some graphical user interface, but we want to actually do it programmatically. This is also useful because we won't go over interfacing with remote computers that much, but basically, if you ever wanted to remote into another computer, it's not going to have a graphical user interface. And so you'll, unless it's some fancy thing like RStudio does sometimes, but whatever. You'll basically need, in order to copy things and move things, you'll need to know these command line tools. That's incredibly useful. So while I'm stuck at home because of the pandemic, and this computer is decently good, but like, it's not good enough to run some of the stuff that I want to do and that my lab members want to do. And so we need to be able to remote connect to those machines and run those analyses on existing lab computers. And so how we can sort of see how good this computer is or how good it's not is also its own command line. And so I'll quickly go over that, and then we'll go back to sort of moving and copying files. And so how you can see how your computer resources are being used is using the top command. So top opens up this thing that's pretty ugly, but gives information that is necessary. And so it tells you in terms of kilobytes, your total memory, your memory in swap, depending on your setup. So this might not even work for some setups. If you're on like Windows, it'll hopefully work. It should work. I'm not certain, but it should work. It should work. And then it also gives you information on free, so how much memory is not being used. And then it gives you information on individual level processes. And so it gives you information on CPU usage and memory usage per process, as well as how long it's been running for, what it's running, et cetera, et cetera. Super duper useful. So we can exit that by using Q, just type in the Q. It gets rid of that. If you're interested in using a Linux operating system, I would recommend installing HTOP instead. You can do that. Oh man, I'm still on that. It used to be apt-get, and then I changed it, and they got rid of the git, and so I still type, and it both work, but I still type in apt-get out of, I don't know, nostalgia. So apt, I'm still going to do it, git install htop. And so this is a command to install a program htop. So install apt-get just means get it, and then sudo, it stands for sudo privileges, and so the super user privileges. And so whenever you use sudo in a Linux operating system, it's going to ask for your password. I don't even know how you use sudo in like a Windows machine. I don't know what's going on there, but hopefully it works. And then you can run it htop, and it just looks a little prettier. And so this, you see I have 8 cores, I guess 4 physical, hyper-threaded, and then, I don't know, was it 40, some random amount of memory that I shoved into this machine at some point. You see it's running Spotify, which is just running in the background. I'm not listening to music right now, I promise. As well as just other processes. So you just see Google Chrome and then Zoom, et cetera, et cetera. So let's get back. So that's how you monitor system resources so that you don't overload your machine. Or you can also kill things that are running from top or htop. So let's get back. We set up our test directory. We have our README. We're ready to go. But let's say we want to move something from the home directory into the test folder. So we change directory and go to that high level. And let's say we want to move speedtest.csv. Let's say that's our data. We can either move the file, which would physically change its location, to our test subfolder. So that's the same thing as a cut and paste. Or we can copy it, which is the same thing as a copy and paste. Copy, CP, and then we just give it the 2 paths, and that's the file that we want to be moved and where we want that file to be moved to, in that order. And so the file that we want moved is in this working directory, this directory called called home./tad, and the file is called speedtest. And we want to move it to the test folder, or just, copy it to the test folder. So we see when we have ls speedtest is still there. So we use our wildcard and we say, give me anything that starts with SP. And it says there's 2 things. There's this R Markdown document that I've been pushing along for a side project, and there is speedtest.csv. And then we can change into our test folder, use ls, and now we see we have our README and we have speedtest.csv. Super duper useful. And if you wanted to move it, it would be the same exact command, except you just use mv to move. So cp to copy, mv to move. And when you work with remote computers, it's pretty much the same, except you'll just use SCP, which stands for Secure Copy Protocol. And that's a way And so basically what I'm trying to say is the things that you learned here are directly applicable to higher order things like working with remote machines and running things on a server or a cluster. All right. I think that is all I actually wanted to cover with the Unix command line. And so I'll also upload the Git and GitHub tutorial, and hopefully this has been informative. Yeah, if not, if you're confused on anything, leave a comment in the section below, or if you're an LSU member taking this course for credit, I'll talk to you in the other lecture. The paper discussion that we want, or that we'll be reading, focuses solely on Git. And so the shell tools really aren't gone over. So we'll still set aside some discussion time to talk about what all you can do from the command line, which is everything. I can open Spotify and open the process. I can use Pandoc. I can open Google Chrome, right? These are all just things that you can start from command line. And so it really gives you sort of complete control over your underlying subsystem. So we're going to change directory. We're going to remove recursively test. I'm just going to delete all that hard work we just did. And it's done. And with that, thank you for your time, and I will catch you in the next video. Stop share. See you later. Okay, there we go. So today I wanted to present sort of two different things. One is Git as a sort of version control language that allows you to do local version control, and then also GitHub, which is separate because that's the web platform, that's the web interface. And so you can use Git locally on your machine and not use GitHub because there's other services like Bitbucket or things like that. Or you could use GitHub, which is sort of the in vogue web platform that interfaces with Git. So to start, I'll define sort of what is Git. And it's actually kind of funny, it was invented by a Finn. It was invented by Linus Torvalds, the creator and leading force behind the Linux kernel, to basically organize and version all the files that you had for the operating system. And so a lot of times we think about Git and a lot of these tools, and we say, like, who really uses these? Do we have to use them? And so I think the stereotype is like this developer guy who has like 4 screens and is like hacking away at code in a basement somewhere. But I don't think that's really the case. And hopefully I'll be able to convince you during this short tutorial that this is not the case, and that actually Git is for everybody who wants sane project management, basically. And so at its heart, Git is a simple version control language, much like Subversion or other options. And so what it does is it just allows you to track files through time. Additions of files, deletions of files, and changes to files. And why that might this be useful is I think a lot of us have sort of run into this situation in which we create a file and we call it something like final or manuscript or something like that. We send it to a collaborator, they comment it up, and it changes. Like files, until they're published and maybe even beyond, are dynamic entities. And so we get in this situation where we say final, revised, final with the co-author's initials, if you've gotten that one before. I've gotten that before. And just like the really poor version of semantic versioning that sort of leads into chaos. It's not useful because now you have like 20 different versions of the same file. And so what Git allows you to do is sort of get around a lot of this. And so if you ask the Git developers how Git works, you get this really confusing schematic. But basically, what it's saying is you have a file that's just named file. It's not named file 1.2, 1.3. And you can version it through time and take sort of a snapshot of that file at a given time.
and then it can change. And it can be accessed by multiple computers. And so on the left, you see computer A is accessing the file, or the version sort of 3 of that file, and then meanwhile computer B is accessing version 1 of that same file. But it's a little bit confusing, and so I'll go into sort of how it actually looks, and sort of try to wade into some of the jargon. Because really, like, at its heart, it's simple, but all the jargon is the steepest and most annoying part of the learning curve of using Git, I think. And so this is basically a time series going from left to right of my commit history. A commit being the snapshot of what I'm doing, what I have on my local machine. And so the repository containing manuscript code and data. And so it started, and it goes farther back, I think. And so each dot here is a commit that I sent to GitHub. This is GitHub's, one of GitHub's interfaces. I'd also like to use, and so the black line corresponds to the master branch. And so a branch is, I'll go over that a little bit more later, but basically, whenever you want to add new functionality to a project, you'll branch it, and it basically copies what's in the repository, what's on that master branch, which is like the best version, and then puts it into something new, that you name something unique. And so I named this one null results, because I had this idea of incorporating a null model into the analyses. But I wasn't sure if it was going to work out. It could have been the case where it gave garbage results or the reviewer didn't like it. And so I branched the repository as to not pollute that master. And then eventually I was like, actually, this is good enough to be in the master. And so you see it diverge on June 21st, and then a week or two later, it goes back. It merged into the master branches. And so those changes are now part of the master. And so each one of these commit messages, each one of these little nodes, these little black nodes, actually corresponds to sort of a point in time and the status of a project. And so here's another XKCD comic showing that you can have messages, and it's really important to have good messages that go along with each one of your commits. And so when he starts out, or he or she starts out, they say, created the main loop and timing control. So something that's informative that you can look back on and say, this is what I accomplished with this commit. And then sometimes, as the joke goes, the commit messages get less and less meaningful. But hopefully you want to avoid that. You want good commit messages. Also, I wanted to take a brief aside. So I'll be teaching, telling you about Git as it works through the command line, because that's how I interact with Git. And if you've downloaded Git and you're on a Windows machine, it ships with Git bash, which is basically just a shell that you can utilize the same commands that I'll show here. Or you could also use a GUI, a graphical user interface. There are many of them, and I don't have much experience with them, so I can't really help on that front. But everything should be sort of the same. And as well, you can use Git sort of directly through R, or RStudio rather. And so for those of you who use RStudio, this could be a good way to get into Git. And so now I was actually going to go and just cover a simple example that covers some of the jargon, that covers some of the workflow. It's just sort of like a live demo. Does anybody have any questions at this point? Okay, hopefully I'm not being too unclear. That's too small. Okay. I made a special thing for this task with massive font so we all can see it. And so I thought that it would be a good use case to show you how I versioned this tutorial. And so we're in the command line, and we can see all the files that go into making this presentation. And so we have the presentation tech file, we have a Readme file, which says something about the presentation, where I gave it, whatever. As well as a notes file that contains my sort of script that I'm casually glancing at on this screen so as not to wander too much, as well as a figures folder. And so if I wanted to initialize this as a Git repository, which I've already done, I would just type in Git, which is how any command starts. Is that too low, or can you guys see that? It's good? Nice, okay.
Maybe on the end you could go and click the buttons under the table to make the shaking go away.
Oh, there's a way to do that?
There's 2 buttons there, and when you switch them, first click the other one and then click back to this one, it often goes away. At least it reduces it. There you go.
Oh, nice. Okay, cool. I thought that was just my eyes. And so we can type in git, and that's too much. But basically, if you type in git, hit enter, it gives you a list of all available git commands. And then if you wanted to initialize the repository, you type in git init. This is already a git repository, and so that doesn't really matter. Another command that is useful is git status, which basically says, what is the status of the current, the branch that you're on relative to other things, relative to the upstream is what it's called. And so we can look at what branch we're on by saying git branch. And so there's only one branch here, which is pretty common, and it's called master, just by default. We can also see the log. And so basically I've been committing to this branch as I built the presentation. And so every time I thought, oh, that's good enough for a commit, I would commit it, and this is all local. And so basically, this shows that on October 21st, I added my actual script. I added my notes of what I was going to say. And we can scroll down and see, at one point on October 18th, I made silly tweaks to spacing. I made sure the tech code was pretty. And I guess I did the entire presentation on October 18th. And so you can see a nice time series of how it looks. And this is independent of the internet. This is just on my local machine. But it's a really nice way. And so if I wanted to go back and see, this is my initial commit. If I wanted to go back and revert to a previous version, let's say I hated the way I went with it, I wanted to go back to the actual skeleton slides and redesign the entire thing, I would simply use git revert and then hand it basically that super long commit identifier. And then the files would revert back to that state. Let's see what other commands I wanted to cover. And so if I wanted to add more functionality to this, let's say, I don't know what I'm going to add, but in order to create a new branch, you type in git checkout. The -b argument corresponds to the creation of a new branch, which you will then name. And so you use the checkout command to switch between branches. And so what that does, which is really alarming to see at first, when you first see it, is if you're doing it locally, it changes all of the files within your local directory, or it appears to. And so if you're using you open your window manager, and it says files A, B, and C. If those files aren't on a separate branch, when you check out and switch branches, you're going to see a completely different set of files, like A, B, C, and D, or just D. So don't be alarmed if that happens. Because when it first happened, I was very alarmed. They've lost a bunch of work. And so let's just name this branch new branch, and now boom, and now I'm on a new branch. And so we can say git branch again, and it will say the master branch exists as well as this new branch called new branch. All the files are still there, and now we can make changes to them, halfway some new functionality, and then eventually maybe merge it back into the master. Ideally, the master is where it's the best copy, the immutable copy. And so some people actually will protect their branches. That's not important. So is there any questions about this general design? So basically the commands that you'll be using, actually, yeah, that's a good point. Okay, so let's just actually make a change. Let's make a change to the Readme file. And so we're going to open up just a text editor, and it says blah, 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 this contains files. And so I'm going to type in, this is a change. I'm going to save it. Okay, and so now the Readme file has been altered. It is something new. And so how I go about, so let's say you have a manuscript, you've hacked away a bunch of functionality to it, you've written a bunch of words, and now you want to actually make that commit, you want to version it. And what you'll do is you'll say, first you'll check on not the status, stat-wise. You check on git status and it says, hey look, you've made some change. You modified a file. It'll also tell you if you deleted a file or if you added a new file. And so from this we can say git add all or git add just the file that we want. Right? So you can either add everything in your repository and version everything at once, or you can just add individual files. So let's add the README. Now we check its status again, and now it's green, which means it's staged for a commit. It's ready to be committed. And then all we have to do is type in git commit. -m corresponds to that helpful message that we put in quotes, and we say added some words to the README. Boom, it's done. And now if we look at git log, it's right up top there. So now there's a version where I can switch back away from that. Okay. So does this all make sense? Super useful. You're convinced? That is Git in a nutshell. That's all you'll basically need. I'll also go over, after this live demo, I'm going to switch gears and just show you around GitHub. Because right now, this doesn't actually talk to the internet, in a sense. And once you talk to the internet, you have to do a couple different things. Yep.
I'm not really sure about what happens before this stage. How am I connecting it to my local repository? Like, where do I start?
With the git init command. And so basically, like, this is just this is a folder that just on my local machine that's called Git Tutorial 2018, and it contains all the files necessary to make it, including a make file. So we can type in make, and it does all this, and it's just going to remake my presentation, which is taking a little bit longer than I was hoping. Okay. And so there it is. So this ideally would contain, as I sort of discussed in last lab meeting, this would contain a folder called analysis, a folder called manuscripts, a README file. It would be like your entire project as you see it. Even if it just starts with like a protocol, that's fine too. It just needs to be encapsulated in some folder environment that then you can create. You can use git init. And what it does when you type in git init is it just creates, that's gibberish. It creates that folder right here, which is just a hidden folder that sort of has all the information about previous commits and such like that. Does that make sense?
Yeah, but what do I do before that? If I don't, I open RStudio and then...
Oh yeah, that's a different interface. You can also you can initialize a repository from RStudio as well.
Okay.
Which is still the general thing, right? You have a folder that contains all of the data and all of the stuff that you want to turn into science. And so you take that folder and you point to that folder via either RStudio or via the command line, and Git's like, all right, let's do this, and creates the .git folder. And then from there, you can properly version. From there, you can set up integration with GitHub or Bitbucket, and you can start committing and pushing changes. Is that a little bit more clear? Sort of. I think maybe it'll become more clear as we go on. Because now I'll introduce GitHub, and maybe that'll help.
You use this for manuscripts as well?
Yes. Yeah, I think that's where it's actually most useful. It's good for analysis, but I feel like my analysis pipeline tends to be pretty linear, whereas my manuscript writing tends to be non-linear. And we'll go over sort of examples. I can show you some repositories once we get into where it's useful for manuscript writing. And so switching from, this is Git on my local machine, and now I want to actually have Git on somewhere out there in the real world. And so the usefulness of this is code sharing, is collaboration. You have collaborators that also use this. They can contribute in real time. And the progress of the manuscript analysis, whatever you're doing, can be tracked. And so GitHub itself is just a sort of web hosting, web development platform utilizing Git. And so who uses GitHub itself? It does tend to be larger tech companies, so it's unlike that where I was like, hey, it's for everyone. In the previous slide, GitHub is actually largely used by a lot of techies, like Google, Facebook. However, I think that a lot of the tools that are developed by these people can be used by ecologists, right? And so Facebook Labs created a great time series forecasting tool called Profit, which I think is grossly unutilized in ecology. They have the graph database. Google has a ton of research and stuff like that that goes into tools that can be used. As far as like why I think we should use Git and GitHub, but specifically GitHub, code sharing, issue tracking, and so assigning tasks among collaborative groups, or even just assigning tasks for yourself that provide you a nice like sort of forward timeline of what you want to complete and when you complete it. You can also track progress, and so I maintain 2 R packages that are hosted both on CRAN and GitHub. And you can track milestones. You can say, oh, I just released version 1.1.0, so major version 1, minor version 1, and things like that. And I also had a little note where a lot of people think that if you just have a GitHub repo that contains all the code that you need to reproduce a manuscript, that's good enough. And I would say like that's not. And I recently read like a bunch of stuff on Twitter about this as well. It's sort of a disagreement, so I wanted to sort of like take a stand. Version control is great, and GitHub is great, but GitHub will be like dead in 10 years, right? The way things go, it's fast turnover, and you'll be using probably a different service, GitLab, Bitbucket, one of the others. And so GitHub repositories aren't citable. You can't, they're not permanent. They're sort of inherently dynamic. It's why you can use things like milestones to sort of revert and see what the project was at that point. But yeah, as far as releasing code and data for manuscripts, don't use GitHub unless you have the Zenodo integration. But even then, it's like hinky. Okay, so now I'll just like stop talking about that and just show you the GitHub interface, and then we can go back to the command line, and I can show you how I will actually version this Git tutorial on GitHub. And so let's pull up GitHub. Is it Control Plus? Okay. And so the things that I wanted to go over. Okay, let's just do this. How many of you have signed up for a GitHub account? Like explored it? Nice. Okay, sweet. So you've seen some page that looks similar to this, where it has a stream of your recent activity, what you've been up to, and I can show you via the Helsinki. And so I set up an organization for rec that shows and tracks largely my projects, but also I think somebody else might have a repository on here. And so you can see each repository. So it starts with organization and then / the name of the repository. And so we can see the structure of the repository as I had sort of previously described. And so you have a small description where I say this is talking about persistence times in the Olin metapopulation. And then it contains folders. This is a presentation I think I gave close to when I first arrived. This is the analysis folder, the manuscript folder. It naturally renders the Readme folder, and so anything that you call Readme and push to the repository, it will show beneath it. And then you can see the files themselves. If we just scroll through here, it's the tech, the PDF, the associated files needed for compilation. And so this is the view that you have. You can see the branches when you click on here. And then these tabs are where all the sort of magic happens. And so if you want to file an issue, you can do so there. And so you leave some sort of informative information about what you want to do in the future with it. I want to get this published in Science. Not really, but something like that. And then it allows you to track your progress. This is not the greatest repository for this, but we can also look at what are called pull requests. And so remember when I showed that linear flow of that black line, and that was my master branch, and then I had the null results sort of popping out. When I merge it back in, it's what's called a pull request. And so that's when I want to merge the two branches. In the GitHub framework, you submit a pull request. And so when you have multiple branches, you hit on new pull request. This one doesn't have multiple branches, and so it's just comparing master to master, which doesn't make much sense. But we can also see a commit history, and so in this here, and so it's that same thing that I typed in when I typed in git log. That same history is here, and so we can see my initial commit and then what I've done each time. And I'm glad this one, I'm glad this one is in relative. It's decently informative, but I violate my own rules and have some less than informative git commit messages. What else do I want to show? This is just sort of superfluous, but you can see when you have multi-collaborator projects, who's committing where and who's changing what. Oh, that's what I wanted to show. Okay, so we go to the code, and we go to the commits, and we can see my most recent commit, and it shows you exactly what was changed. And so 3 days ago, I committed this where I added a figure. This is our code. And so before it wasn't there, and now it is there, where I wrote some beautifully formatted R code to make a figure about grazing pressure and the influence of that on something, resource abundance and grazing pressure in the Olin system, for a supplemental plot for this paper. I also added some citations to the bib file. And so you can clearly see any and all changes that I've made. And you can diff them. This can also be done on the command line. So like previous, just saying git diff, D-I-F-F. And then you can also comment on the commit. And so if I say, I don't like these changes, or I have something to say about one of these files, you can do that. And you can also, you should be able to comment directly on specific files and changes. And so if you had the manuscript text, which I don't know if is in here, it'll show old version and new version, with new version, new additions in green and deletions in red, and you can actually comment directly on that. And so collaborators can actually basically provide feedback on manuscript edits via this platform as well. I haven't messed around too much with that because a lot of my collaborators don't really use this. And so some do, some don't. And so that is really useful. Okay. So now let's go over how we actually interface between Git and GitHub really quick. And then I think that's pretty much all I have. So just to link the two together. And so we can go back to, I don't know where I put it. We can go back to our command line. Can everyone read that text okay, or should I switch to the other? Okay. So we can go into the Git tutorial workflow. It's already all there. And all we have to do on the GitHub side, there we go. It's a little better, I think. We go up here, and we say new repository. We name it something. It doesn't have to be the same name as the folder that you have, but it's kind of useful. So we name it Git Tutorial 2018. Add an informative description. Say Git tutorial for University of Helsinki. I'm going to set it as public. You can also choose private. Private repositories cost money unless you're an academic, which is awesome. And so you just have to go to the GitHub education branch or whatever. You fill out a quick form, and they give you as many free repositories as you want that can be versioned privately. And so if you're just not ready to share that stuff, you can do that. If you're not ready to share certain aspects of your files, but you still want to version them on GitHub, you can use a git ignore file. And so let's say you have sensitive data that you can't share, but you want to make the code and the manuscript public. You can do that by, I don't have one in here, but it's basically you just name a file .git ignore, one word, and then treat it as a text file. And so you open it up and you give the path of the thing that you don't want to be on GitHub. And so it's still on your local machine, but it's just not on GitHub. And so we want to set it public. We already have a README, so don't need to do that. And we say create repository. And what it does is it creates this empty repository, maybe. It's working, it's thinking. That'll basically just be a blank slate. And then we want to get what we have locally to GitHub. And so here we go. We have something now called Tad Dallas, which is my username, and the repository is called Git Tutorial 2018. And so how this now, okay. So this is some of the Git code, very similar to sort of what I initially talked about, where we basically have git add, git commit, and now there's a new command. There's two new commands. Git remote add, which basically remote is like the final destination on the web of this branch. And so the remote always follows the same structure. It's github.com/username/repository name.git. And so we'll have to set that up. Okay, so we're in, now we tell it, why is it doing that? What did I do? There we go. I just called it version 1, that's fine. And so now it knows where to send my local Git folder. And so we can now do that. Nothing's really changed. This log is still there. And now we use the push command. And so the push is how you actually take your files that are made locally and get them on GitHub's web interface. Master corresponds to the master branch, and origin1 is the name of that remote. And so we type in the username, and then it's going to ask for a password, which I have stored away for just this occasion. Sorry, it's super long and all numbers. And so we type that in, hit enter, and it says repository not found. Shouldn't say that. I don't know why it's saying that, but let's just pretend that worked. It should have worked. And yeah, and there we go. And then once you update that, it'll, why is it doing that? Remote repository not found. It might be like my internet connection. Yeah, it's acting as if I didn't create that repository. Okay, I'm not even going to go into it. But basically, it's acting like I didn't create the repository. I did, and it should show up. And then you have it on GitHub, and everything is hunky-dory. So does any of this make sense? We have questions about Git or GitHub. I can just scroll around and show more of the utility of it. You know, it's sort of a lot to take in at first, but incredibly useful.
I think it probably would demand like a hands-on kind of tutorial thing. But
Yeah.
I think this was a very good introduction to how to get started.
Yeah, and there's other resources. Yeah, and so this is, I'll make this actually publicly available on GitHub, and I can share it with you guys. This is just some good web resources for learning Git, both with RStudio and by itself, as well as a list of GUIs. So graphical user interfaces that you can use to interface with your repositories both locally and that are versioned on a web hosting platform like GitHub or Bitbucket or GitLab or any others. Ta-da! That's good.
Thank you.